Yeah, welcome back. In this class, we are going to discuss about the gate logic. Okay. Now, already we had seen in the last class what is meant by gate logic. If the input is given to the gate terminal of metal oxide semiconductor, then it is known as a gate logic. Okay. If the input is given to either source or drain terminal, then it becomes what? Switch logic. Okay. Now we will talk about the static CMOS and the implementation of a gate logic with some basic gates and other complex gates. Is it clear? Okay. Now you can observe that we are discussing about the static CMOS, a complementary metal oxide semiconductor. If you observe very important point here, okay, the complementary metal oxide semiconductor consists of two networks. One is pull-up network and another one is a pull-down network. Okay, the input is commonly given to the gate terminals of pull-up and pull-down network, and the output is collected between the two terminals. That means the drain terminals of pull up and pull down network, and pull up network is connected between a supply VDD and an input, and pull down network is connected between an input and the supply VSS. Can anybody try to tell what is meant by pull up network basically and what is meant by pull down network basically? Absolutely, pull up network is basically what? A PMOS net, and pull down network is basically what? An NMOS net. Is it clear of you? Now we will see some of the gates how designed using this static CMOS concept. Remember, in the static CMOS, okay, what are the features means? It is considering low power, okay, and good noise margin. It is having a good noise margin. But if you observe that since you are having two networks, what is the drawback? In a sense, more number of transistors required, okay, that is a drawback you can talk about. Now, to overcome this one, we should move to the other forms of CMOS logic that are also referred as alternate forms of CMOS logic. Now, before that, we will talk about how the basic gates, that means and or not NAND nor gates are designed, and we will see about other complex gates. I think so. If you didn't refer my videos, how to design any boolean expression using CMOS and NMOS logic, if you refer that, then the same concept I'm going to repeat here with a little bit explanation. Therefore it is very easy to you. Please try to refer that. Is it okay? Then we will talk about some of the basic gates. Now first of all, you may observe that, yeah, now you can observe the example of what I have considered an OR gate, an example. You know this keyword, whether you have remembered this keyword. What is this? Absolutely. P stands for PMOS. This A AND logic, or it may be an AND logic. How the PMOS should be connected? Absolutely in parallel. Is it clear? Now you can observe what is the Boolean expression. This is what NOR gate. We know very well NOR is nothing but A plus B whole complement. That means it is which one? R1. Therefore, if you observe this pull-up network is connected in series. Okay, this pull-up network is connected in series. Is it clear? A, B. And this pull-down network, if you observe this pull-down network is connected in parallel. Is it understood? Okay, then you know very well the common input is given to this transistor and this transistor, and output is taken between the drains, and it is what? VDD, and it is what? VSS. Is it clear? Now you can verify that when A is 0, B is 0, then A is 0, B is 0, then these two transistors are turned off, these two transistors are turned on, therefore the output is what? 1. I hope that are clear. Now you can observe that when A is 0, B is 1. When A is 0, B is 1, this transistor will turns off, therefore you do not have any flow here. But here A is 0, B is 1. If you observe that this won't be turned on, but this will be turns on. Therefore, what is an output? If you observe that 0 is an output. I hope that are clear. Now you can observe when A is 1, B is 0. Similarly, A is 1, B is 0. this won't be turns on, therefore the path is up to here, therefore it doesn't reach the output, therefore it stops here. Now you can observe that if a is 1, b is 0 here, this will be in on off condition and this will be in on condition, therefore what is an output? 0 is an output. Is it clear? And finally a is 1, b is 1. Okay, there is no path at all for this one. Okay, there is no path, then this transistor, this transistor, both will turns on, then you are having two paths, therefore what is an output? 0 is an output. Is it clear? In this way the NOR gate is going to be work. If you observe the another example, you can observe which example it is. Yeah, absolutely, it is what? A NAND one. You can observe very clearly. Okay, now will you please tell me, since it is a NAND gate, is it clear? Therefore PMOS should be in parallel, NMOS should be in series. That means this pull up network is in parallel, this pull down network is in series. Now you can observe that if A is 0, B is 0, okay, both transistor will turns on, this transistor will be turns off. What is an output? 1 is an output. Is it clear? Now if A is 0, B is 1, A is 0, B is 1, this will be in off, but there is a path here, but he can observe that A is 0, B is 1, there is no path here, it will come like this and it will stop here itself. Therefore what is an output? 1 is an output. You can observe A is 1, B is 0, A is 1, B is 0, this will be an on condition and there is a path to the output, therefore the output is 1. Now you can observe that here A is 1, B is 0, this won't be turns on, therefore there is no path here itself, therefore it doesn't reach, therefore the output is 1. Now finally you can observe A is 1, B is 1, A is 1, B is 1, these two transistors will be turns off, there is no path at all here, but these two transistors will be turns on, therefore there is a path, therefore the output is what? 0. In this manner the NAND gate is going to be work. Is it understood? And based on this, try to design AND gate, okay, by connecting an inverter here, by connecting a simple inverter here. I hope that are you clear. And this is an inverter. Now if you connect like this, then what is an output here? That is an AND gate. Is it clear? And try to design an OR gate, and try to design an XOR gate, and try to design XNOR gate. These are the tasks for you guys. Will you please try to design, and we will see some other complex gate, how to design some other complex gate. Is it clear? Yeah. Now try to design this complex circuit. Can anybody try to tell how to design this one? Yeah, absolutely. NMOS, these two, if you observe that, first of all try to tell how to design pull up network. Later you may talk about pull down network. Can anybody try to tell? Yeah, how this pull up network looks like? See, you can observe how many inputs are there. You can observe, I will use different color. 1, 2, 3, 4 inputs are there. Therefore 4 PMOS should be required. Then how to design this one? Absolutely. This should be in parallel. Let us consider it is X complement, it is Y, and this should be in parallel. This is X, this is Y complement, and these two should be in series. Therefore these two should be in series and it should be connected to VDD. This entire is nothing but what? This entire structure is your pull up network. Now will you please tell me how your pull down network looks like for the same Boolean expression, X complement into Y plus X into Y complement? Yeah, absolutely, exactly opposite. The pull down network will be like this. This is X complement and it is Y, and it is X and it is Y complement. These two should be connected in parallel, and this should be VSS, and there you have to go to the output side. Is it understood? Therefore if you club these two, how it looks like? Can anybody try to tell? Yeah, absolutely, it looks like, I will show how it looks like. You can observe very clearly. Yeah, it looks like in this fashion. Is it clear? Now you can observe that since the Boolean expression is, what is the Boolean expression? They have given X complement into Y plus X into Y complement. There is no whole complement, therefore you require an inverter. But don't forget, you should not draw this symbol, you should draw this inverter. Is it clear, all of you? That is a very important point you have to talk about. Is it clear? And this output should be given to this, then it is your Y. Let us consider Z, then it becomes it. I hope that are clear. This is one of the complex gate. Then shall we try to design one more complex gate? You can observe this one. I will give the question for you. Yeah, let us consider this is a question. You can observe the question. What is the question given here? You may observe very carefully. X plus this one, you can observe that. How many inputs are there? You can tell. 1, 2, 3, 4, 5 inputs are there. Is it clear? Now can anybody try to tell how to design this? X plus y complement, okay, z plus t into w complement. I will give one hint. Okay, please come with the back side. What is this first one? T into w complement. Shall we try to design what is that, a pull down network or pull up network? Okay, I will tell one thing. I will give a pull down network, then you try to design a pull up network. Later you try to combine these two. Is it clear? Now T into D complement, therefore these two should be in series. Let us consider this is T, this is W complement. For these two, this should be in parallel, absolutely. Okay, this is my, what is that, Z. For this entire thing, okay, for this entire thing, this should be in series. Now you can observe this one. What is this? Y complement. Is it clear? Okay. Now for this entire thing, X should be in parallel. Therefore I will use one more color for this. Okay, X should be in parallel. This should be X. I hope that are clear. Now this entire thing should be connected to VSS and this should be taken at the output side. Is it understood? In this fashion you have to design. Okay, then I will show the entire circuitry, how it looks like. You can observe this entire circuitry. Okay, this is the network what we design. Okay, now just now we design. Is it clear? TW, if you observe that this in series, Z is in parallel with that, then Y complement is in series, the entire for that X is in parallel. Now you can observe this. Okay, I think so in this also they didn't show the pull up network. Okay, you can observe the pull down network, pull up network, and try to design by yourself. Okay, if you want I can design here. Shall we just recall the Boolean expression? What is the Boolean expression they have given? Yeah, absolutely. X plus y into z plus t into w complement. I exactly then said, I think so this may be z, this may be y complement, whatever it may be. How to design the pull up network? These two should be in parallel. Let us consider T W complement. For these two, this should be in what? Series. Okay, let us consider this is Y complement. For this entire thing, Z should be in parallel. Okay, I will take here. This is Z. Okay, for this entire thing X should be in series. If you want to take downside you may take, otherwise if you want to take upside you may take. Is it clear? That is your wish. Is it understood? Okay, this should be taken at outside, this should be taken to VDD. I hope that are clear. In this fashion you have to design. Is it clear, all of you? Thank you very much for each and everyone. Okay, some other complex gates. These are some other complex gates. You can observe these are some other complex gates. Try to practice by yourself, and this is one more complex gate. Please try to practice by yourself. Okay, thank you for everyone. That's it for today's class. Have a nice day. If you are having any queries regarding that, please try to ask in the comment section. Is it okay? Thank you very much. Have a nice day.